Hi everyone, this is me Nehra Nazar, and today I'm gonna take a seminar on the topic Edge Computing in Mobile Devices and Network Architecture. So, here's an introduction to today's seminar. In recent years, the proliferation of mobile devices and exponential growth of data traffic have posed significant challenges to the traditional network architectures. So, the emergence of edge computing has offered a transformative solution, particularly in the context of mobile devices and network architecture. Now, on the third slide, we are going to discuss about the significance of edge computing. That is, why is edge computing important? What is the advantage of edge computing? So, I've written a few points. So, let's discuss it one by one. First, reduced latency. So, edge computing brings computation and data storage closer to the end users, minimizing the time it takes for data to travel back and forth to centralized servers. So, this reduction in latency is critical for real time applications such as gaming, video streaming, and all. Now, we have improved bandwidth efficiency. What do you mean by that? Now, the edge computing is actually reducing the volume of data that needs to be transmitted over a long distance to the centralized data centers. So this optimization of bandwidth uses alleviates you like this optimization of bandwidth usage alleviates network congestion and enhance overall network performance. Then we have data privacy. So when we're using edge computing, it is allowing the sensitive data to be processed locally on devices, which is reducing the need to transmit the data over public networks, thus improving the privacy of data. Then we have real-time data processing. So, what do you mean by real-time data processing? Mobile devices equipped with edge computing capabilities can perform complex computations and analysis on device without relying solely on cloud infrastructure. And the last but not the least, we have about scalability and flexibility. So, edge computing architects are inherently scalable, allowing the resources to be dynamically allocated based on demand. So, this flexibility accommodates fluctuating workloads and supports the seamless integration of new devices and application into the network ecosystem. So, I hope you got like what are the why is edge computing important, and then on the third slide, let's discuss what is edge computing, or yeah, like a definition of edge computing. I've written a simple definition of edge computing. So edge computing can be defined as distributed computing models that brings computation and data storage closer to the location where it is needed. So improving response times and saving the bandwidth. Now we have some key components associated with edge computing. That is edge devices. Then we have what is edge computing infrastructure, and then edge application. So moving on with edge devices such as the smartphones, routers, gateways, so that generates or consume data at the network edge, which is known as edge devices. Then we have edge computing infrastructure. So the network of edge servers, nodes and devices that enables computation and data storage at the network edge. That is known as edge computing infrastructure. And then we have edge application, means software application and services that leverage edge computing capabilities to perform tasks such as real-time analytics, AI inference, and content delivery. Okay. And then I have written some of the benefits of edge computing, which I have already discussed. And moving on to the fifth slide, we have evolution of mobile devices. So, yeah, mobile devices have undergone a remarkable evolution since their inception, transitioning from basic communication tools to sophisticated computing platforms. So, yeah, as we all know, like the early mobile phones was just a primarily analog devices with limited functionalities just for communication. Then we had like the featured phones, then the smartphones, then the advancement in computing power and storage, then the high speed connectivity, and then we have the smartphone innovation and diversification and all those stuffs. So over the years, mobile phones have witnessed a dramatic increase in computing power and storage capacity, enabling them to perform tasks that were only once possible on desktop computing. Okay, yeah, that is what the slide is about. So the evolution of mobile devices from basic phones to smartphones represent a transformative journey driven by technological innovation and consumer demand. So with increasing computing power and storage capacity, modern smartphones have become indispensable tools for communication, productivity, entertainment, and more, like shaping the way we interact with the digital world. Now, I've written the integration of edge computing in mobile devices. So, the integration of edge computing in mobile devices represents a paradigm shift in computing, enabling enhanced performance and efficiency by leveraging localized processing power. So, this integration empowers mobile devices to execute complex tasks and application with minimal latency, significantly enhancing user experience. Okay, so I've written some points about it: enhanced performance and efficiency. So what do you mean by that? Enhanced performance and efficiency. Enhanced performance and efficiency means reduced latency. Then we have like that I've already discussed, and then we have bandwidth optimization, which I've already discussed, and then we have um, like edge computing on mobile devices, and for that we have edge AI processing for facial recognition, real time language translation, and augmented reality, that is AR applications. So talking about a edge AI processing for facial recognition, mobile devices equipped with edge AI capabilities can perform facial recognition tasks locally without relying on cloud based servers. So this enables faster and more efficient identification of individuals, enhancing security and user authentication in various applications such as device unlocking and access control. And for then about real-time language translation, edge computing enables mobile device to perform real-time language translation without requiring an internet connection. So by leveraging on device processing and AI algorithms, users can translate spoken or written text instantly. So which is one of the advantage. And then we have AR application. So AR application overlay digital content onto the physical environment in real time, so requiring high computational resources and low latency for a seamless user experience. So edge computing is enabling mobile devices to process AR content locally, enhancing performance and enabling immersive expensive experiences without relying on remote servers. Then, so coming on to the next slide, we will be discussing about the traditional centralized cloud computing architecture. So that has been a backbone of the digital infrastructure for many organizations, offering scalability, flexibility, and accessibility to resources over the internet. So, centralized cloud computing architecture refers to a model where computational resources, including servers, storage, and networking components, are concentrated in large data centers operated by cloud service providers. So, talking about the traditional centralized cloud computing architecture, we have some key points like data centers, virtualizations, networking infrastructure. So, what do you mean by data centers? Data centers are centralized facilities hosting a vast array of servers, storage systems, that host application databases and other computing resources, as we all know. And then we have virtualization. Virtualization technologies enable the partitioning of physical hardware into multiple virtual machines, which is known as VMs, allowing for efficient resource utilization and isolation of workloads. And talking about network infrastructure, we need high speed network connection interconnect data centers and enable communication between servers and clients accessing cloud services over the internet. And moving on to the challenges of traditional centralized cloud computing. Now, what are the problems if we use the centralized traditional way of centralized cloud computing architecture? We have latency issues. Latency issues means the distance between the end users and the data centers can introduce latency, resulting in delay. There will be a delay in data transmission and application responsiveness. So latency sensitive applications such as real-time communication, gaming, so these experiences, like these performance will be degraded. Then about the bandwidth constraints, we have centralized cloud architecture rely on internet connectivity for data transmission between clients and servers, so leading to potential bandwidth limitation and network congestion. And then we have data privacy concerns like storing sensitive data in centralized data centers, which will be raising security problems, privacy problems, regulatory complaints, and all those things. So these are the challenges about traditional centralized cloud computing architecture. Now, now we'll be comparing about the centralized cloud computing and then about the edge computing architecture. So I have already written about the definition of cloud computing, edge computing, and the key characteristics of cloud computing and edge computing. Now, when we are comparing distribution of computing resources. So, in centralized cloud computing, the concentration of computational resources in remote data centers, and in edge computing, the distribution of computing resources to the network edge closer to the data source. And then when we're talking about the processing speed and latency, centralized cloud computing will be like potential latency issue due to the data transmission over long distance. And coming on to the edge computing, faster processing can be done, that means reduce latency. And then about the bandwidth efficiency, in centralized cloud computing, it will be like it relies on the network and internet connectivity, leading to the potential bandwidth constraints and network congestion, which is not there in edge computing. Like means here optimizes the bandwidth usage by processing data locally, reducing the volume of data transmitted over the network. And then about the scalability and flexibility, edge computing is more scalable and flexible. In centralized cloud computing, it's like offers scalability and flexibility in resources provisioning and the management. So overall, we can say like centralized like compared to centralized cloud computing, edge computing is more better. So centralized cloud computing and edge computing architecture offer distinct approaches to distributed computing, each with its benefit and challenges. So while centralized like cloud infrastructure provides scalability and flexibility, edge computing optimizes processing speed, reduces latency, and enhances bandwidth efficiency by distributing computing resources to the network edge. So the combination of central cloud infrastructure and edge computing enables organizations to leverage the strength of both paradigms, delivering enhanced performance, responsiveness, and scalability in distributed computing environments. Then, the next slide is about the use case of edge computing in mobile devices and network applications, like the applications. Where is this edge computing used? So edge computing is used in traffic management. So the edge computing enables real-time analysis of traffic data collected from sensors and cameras deployed across the city. So traffic flow optimization, congestion detection, all these are done. Then for public safety, like edge devices process data from surveillance cameras and emergency response systems to detect and respond to incidents in real time. So facial recognition for identifying suspects, gunshot detection, so all those kind of things. And then we have about environmental monitoring. So the edge nodes analyze environmental data including air quality, noise levels, temperature to monitor and mitigate pollution and environmental hazards. Then the next application is like the industrial IoT. So as we all know, IoT means Internet of Things. So in that we have like predictive maintenance. So edge computing facilitates real-time monitoring and analysis of equipment performance and condition. So predictive maintenance algorithm detect anomalies and predict equipment failures before they occur and all those kind of stuff. And then about real-time analytics, we have edge computing platforms perform real-time analytics on sensor data to optimize production processes and improve operational efficiency. So analysis of production line performance, quality control and energy consumption optimizations and all. And I forgot a point, I guess, remote monitoring. So edge devices collect and process data from industrial sensor and machinery, enabling remote monitoring of production processes and assets. And in case of healthcare, we have like edge computing helps in like remote patient monitoring, that is continuous monitoring of vital signs of health parameters for patients in their homes or healthcare facilities. So real time alerts for abnormal reading, medication reminders and all. And then we have telemedicine, like in case of edge computing, they supports the telemedicine application for remote diagnosis, consultation and treatment. And then we have medical imaging analysis. Edge devices process medical imaging data such as MRI and CT scans locally to provide timely diagnosis and treatment recommendation. So in conclusion, we can say like edge computing in mobile device and network architecture revolutionizes various industries by enabling real-time data processing, analysis and decision making at network edge. So from smart cities to the industrial IoT to healthcare application, edge computing enhances efficiency, responsiveness and scalability, driving innovation and transforming digital experiences. So that's all about the application of edge computing. And moving on to the next slide, we have challenges and considerations. So what are the challenges of edge computing? All this time we were discussing about the advantages, about the application of edge computing. Now moving on to the challenges, we have like everything has pros and cons. So edge computing also have some challenges. So let's discuss about it. First, connectivity issues. So seamless communication. So the challenge is like ensuring continuous and reliable communication between edge devices and central servers, especially in dynamic and heterogeneous network environments. And then we have security concerns like safeguarding the sensitive data transmitted and processed at the network edge from unauthorized access, interception, and tampering. And about edge device security, the thing is like securing edge devices against potential cyber threats, malware and unauthorized access given their distributed and often resource constrained nature. And then about the standardization, we have interoperability. The challenge is like lack of standardized protocols and frameworks for interoperability among heterogeneous edge devices, platforms, and ecosystems. And about edge computing frameworks, the thing is like fragmentation of edge computing frameworks and architectures, leading to compatibility issues and vendor lock-in. So addressing the challenges and consideration in edge computing is essential to realize its full potential and ensure successful deployment in diverse application and industries. So by overcoming connectivity issues, enhancing security measures, promoting standardization efforts, organizations can leverage edge computing to drive innovation, efficiency and agility in distributed computing environments. And then the last slide is about future outlook of edge computing. So yeah, this is the last slide. So the future outlook means I have some points like anticipated growth of edge computing. So anticipated exponential growth of edge computing in mobile device and network architecture driven by proliferations of IoT devices, 5G networks, AI driven applications, edge computing poised to become a mainstream computing paradigm transforming how data is processed, transmitted and utilized in distributed computing environments. Now we have innovations in edge computing like the 5G networks. So integration of 5G networks with edge computing unlocks unprecedented bandwidths, ultra low latency, high reliability, yeah, and enhancing the performance, scalability, responsiveness. Then we have AI driven edge application. So the emergence of AI driven edge application leveraging machine learning and deep learning algorithms to perform complex tasks locally on edge devices. And then we have like edge native services, like deployment of edge native services and platform tailored for edge computing environments, offering simplified deployment management and orchestration of edge application. Edge native services enable seamless integration with existing cloud infrastructure, hybrid cloud deployments, and edge to cloud connectivity for hybrid computing architecture. Then we have like potential impact on various industries and everyday life like IoT and smart cities. Now industry 4.0 and manufacturing. That is, edge computing facilitate digital transformation in manufacturing industry, enabling predictive maintenance, real-time quality control, adaptive production processes, and all. And in case of healthcare and telecommunication, telemedicine, edge computing transforms healthcare delivery and enabling remote patient monitoring, telemedicine consultation, as we talked about in case of application of edge computing. So, yeah, as a conclusion, we can say like um, edge computing have a lot of potential, of course. And going on to the last slide, we have like the conclusion about all the points we discussed in the seminar about the definition of edge computing, their benefits, their applications, the challenges, and all, and the comparison of edge computing with the traditional cloud computing. And yeah, that's all for today's seminar. I hope you it was an informative session and I hope you got an idea about edge computing. Thank you so much for listening. Yeah, thank you.